This this module is on neighboring group participation in aliphatic nucleophilic substitution reactions. Neighboring group participation is also called as anchimeric assistance. The word anchimeric is a Greek word which means a neighboring part. When there is a suitably placed functional group or atom present in a substrate, apart from the leaving group, it affects the rate and stereochemistry of the substitution reaction. This can be called as intramolecular catalysis. More information about this we will be discussing in the next slide. Functional groups at the carbon next to the reaction center are called neighboring groups. The mechanism by which the neighboring groups are speeding up the reactions is known as neighboring group participation. I have given 4 pairs of reactions here. In this reaction we find this is the reaction center where the nucleophilic substitution has to take place. And this is a carbon next to that. In this carbon there is a functional group thiophenyl. This sulfur with its lone pair can behave as a neighboring group in pushing out the chlorine as chloride. Whereas in this molecule there is no neighboring groups to enhance the reaction rate. So in this molecule, nucleophilic substitution can take place by anchimeric assistance, by neighboring group participation. That is why this molecule undergoes nucleophilic substitution with water 600 times faster than the molecule which is not having neighboring group. The other pair, if you look at, this molecule reacts with the trifluoroacetic acid 3000 times faster than this molecule. It is because of the neighboring group here. The aromatic ring can behave as a neighboring group using its pi electron pairs. And here I have given another pair of reactions. Here this molecule reacts with acetic acid, which means it undergoes acetylysis 10 power 11 times faster than this molecule because this molecule has got a neighboring group, the pi bond. This pi bond will attack from the backside of tosylate and will push out the tosylate. In that way, it does the role of internal catalysis. And in this another pair I have given, this molecule reacts with acetic acid or undergoes acetylysis 670 times faster than this because I have given in the other slides, this molecule if you draw in the chair form, the acetate group can behave as a neighboring group to assist the removal of tosylate and will enhance the attack of acetic acid. Can better explain the neighboring group participation. So here it is this point at which nucleophilic substitution has to take place where the chloride is leaving group. Next to this carbon, we have this carbon with sulfur. This sulfur is going to behave as a neighboring group in pushing out the chloride. Whereas in the reaction B, there is no neighboring group present. And because of the presence of this neighboring group, this reaction A is 3000 times faster than the reaction B. How this neighboring group participation works out, we shall discuss with the next slide. The mechanism for the neighboring group participation. In this molecule, the carbon bearing chlorine is the reaction center. This chloride has to be replaced by a nucleophile. But next to this reaction center, the neighboring carbon has a neighboring group which has got a sulfur with a lone pair. In this reaction, sulfur attacks from the backside of chloride, which is a SN2 reaction, and pushing this chloride out, and that results in the formation of a sulfonium ion. So therefore, one SN2 reaction has taken place here, and this is the slow step and rate determining step. And now once sulfonium ion is generated, sulfur and electronegative atom is holding positive charge. Therefore, in order to neutralize sulfur, this bond has to go back at a faster rate. Now this nucleophile attacks at the backside of this ring, which is again a SN2 reaction. So water, the nucleophile attacks from here and pushing this bond back to sulfur, resulting in the formation of a protonated OH, which after the removal of a proton ends up with an alcohol. So the overall reaction here is chloride has been replaced by hydroxide. A simple nucleophilic substitution, but this reaction is accelerated by the neighboring group participation. Reaction we discussed now, the cyclic sulfonium ion is the intermediate, and this labeled carbon is the one that was holding the chloride. Now the nucleophile can attack both the labeled as well as unlabeled carbon here. Since both the carbon atoms are in similar environment, the nucleophile can attack any one of the two carbon atoms. The attack at carbon 1 as well as carbon 2 have equal probabilities. Therefore, we end up with two different products, one in which OH is connected to the labeled carbon, another one in which OH is connected to the unlabeled carbon. So this is an evidence for the formation of cyclic sulfonium ion intermediate by neighboring group participation. We can propose a general mechanism for neighboring group participation. This is the substrate where the leaving group is connected to this carbon, which is called as reaction center. The next carbon is neighboring carbon, and the functional group present in this neighboring carbon is called neighboring group or ankymeros. In the first step, the neighboring group attacks exactly from 180 degree with respect to leaving group, that is backside attack, a SN2 reaction by which the neighboring group pushes the leaving group out. So one SN2 reaction has taken place, resulting in the formation of a cyclic ion. And this cyclic ion is unstable because it is holding positive charge on an electronegative atom. Therefore, the incoming nucleophile attacks backside from the backside of this cyclic ion. So this is another SN2 attack, and which results in the formation of a new bond between carbon and nucleophile. And this is the final product where the nucleophile is exactly oriented in the place where the leaving group was oriented. So because of this, there is a retention of configuration. So nucleophilic substitution with neighboring group participation involves two steps. Both the steps are SN2 reactions. So two consecutive, one SN2 reaction will lead to inversion of configuration, and two consecutive SN2 reactions lead to retention of configuration. Inversion followed by another inversion gives retention. And this is how all the neighboring group participation, all the nucleophilic substitution with the neighboring group participation are taking place. Thank you. We shall meet in the next module.